Good morning to everyone. My name is Ramesh, Assistant Professor, Department of Commerce and Management Studies, Soundarya Institute of Management and Science, Bangalore. Now I am going to explain the topic is assignment problem. This topic is under unit number 2, Mathematics for Business Management 2, second semester BBA Aviation Management courses. Now I am going to explain about assignment problem. What is assignment problem? What are the methods will be used? Then how to solve the problems in the assignment. Assignment problem is a special case of linear programming problem, and also is a special type of transportation problem where objective is minimize the cost or time of completing a number of jobs by a number of person. 4 jobs. How to make minimize and assign the jobs? That is what we are going to study in this problem. In other words, when the problem involves the allocation of n different facilities to n different tasks, it is often termed as an assignment problem. The model primarily usefulness is for planning. The assignment problem also encompasses an important subclass so called shortest or longest route models. The assignment problem model is useful in solving problems such as assignment of machine to jobs, assignment of salesman to sales territories, traveling salesman problem, etc. It may noted that n facilities and n jobs, there are n factorial possible assignments. One way of finding an optimal assignment is to write all the n factorial possible arrangement, evaluate their total cost and select the assignment with the minimum cost. But due to heavy computational Odin method is not suitable, this chapter concentrates on efficient method for solving assignment problem that was developed by Hungarian mathematician D. Koenig. So we will call it as Hungarian method to solve the assignment problem. Formulation of assignment problem. Formulation of an assignment problem. Suppose a company has n persons of different capacities available for performing each different job in the concern, and there are same number of jobs of different types. One person can be given one and only one job. The objective of this assignment problem is to assign n persons to n jobs so as to minimize the total assignment cost. The cost matrix for this problem is given below. So in this format, worker and job, how much you can able to allocate it? 1 to 1. Final allocation should be one job, one person. Should be one. That is one worker, one job only should be allocated. The structure of an assignment problem is identical to that of transportation problem. But here we are going to study assignment problem of this unit. The formulation, the assignment problem in mathematical programming format is like that: xij equal to 1 if the job is performed by worker I, otherwise it is 0. So for I equal to 1 to n, j also 1 to n. In the table, Ci is the cost of performing the jth job by the worker. Optimization model. Minimization of z equal to c11 x11 plus c12 x12 plus etc. cnn xnn. This is general form of the here objective and restrictions are equal to 1. That is, constraints are equal to 1. The values always to be 1. Comparatively linear programming method. Xij equal to 0 or 1. Whether it is assigned or not. Like that will be considered. In sigma notation, minimization is that summation I over n to n j equal to 1 to n Cij xij subject to the constraint summation I equal to 1 to n xij equal to 1 for I equal to 1 to n. Similarly, j equal to 1 to n xij equal to 1 for j equal to 1 to up to n. This is the sigma notations of transport assignment problem. An assignment can be solved by transportation method, but due to high degree of degeneracy, the usual computational techniques of a transportation problem will become very difficult. So we are not going to use for the transportation method. We are going to use the special method is available such solving such type of problem. That method name is called as Hungarian method. Assumption. Before solving this problem, we need to assume what are the assumptions can be considered. Number of jobs equal to the number of machines or persons. Each man or machine is assigned only one job. Each man or machine is independently capable of handling any job to be done. Assigning criteria is clearly specified, that is minimizing cost or maximizing cost. Both the way it will be solved here. Hungarian method of solving the assignment problem. This is an efficient method for solving assignment problem. This method is following principles. If a constant is added to or subtracted from every element of a row and or column, the given matrix of an assignment problem, the resulting assignment problem has the same optimal solution as the original problem. Hungarian algorithm. The objective of this section is to examine a computational method and algorithm of deriving solution to the assignment problem. The following steps will be followed. Steps in Hungarian method. Identify the minimum element in each row and subtract it from every element of that row. Identify minimum element in each column and subtract it for every element of that column. First row will be considered, then column will be considered. Make the assignment for the reduced matrix obtained from steps 1 and step 2 in the following way. First one, for each row or column with a single zero value cell that has not been assigned or eliminated box, that zero value as an assigned cell. For every zero that becomes assigned, cross out all other zeros in the same row and the same column. Third one, for a row and column, there are two or more zeros and one cannot be chosen by instruction. Then you are liberty to choose the cell arbitrarily for assignment. That means the particular row, two or more zeros are there, then we can select our own method, our own self. Ourself we can able to select it, and then other zeros will be cancelled. The above process may be continued until every zero cell is either assigned to or crossed. An optimal assignment is found if the number of assigned cells equal to the number of rows and columns. If in case you have chosen a zero cell arbitrarily, there may be an alternate optimal solution. If number of optimal solution is found, go to the step 5. Draw the minimum number of vertical and horizontal lines necessary to cover all the zeros in the reduced matrix. That is mean obtained from the step 3, adopting the following procedure. That means maximum zeros covered minimum number of lines. Mark all the rows that do not have assignments. Mark all the columns not already marked which have zeros in the marked rows. Mark all the rows not already marked that have assignments in marked columns. Repeat step 5 until no more rows or columns can be marked. This the procedure could be followed. Draw straight lines through all unmarked rows and marked rows. You can also draw the minimum number of lines by inspection method. Select the smallest element from all the uncovered elements. Subtract these smallest element from all the uncovered elements and add it to the elements which lie at the intersection of two lines. Then we need to follow some procedures. We need to go to step 3 and repeat the procedure until you have arrived optimal assignment. For the time being, we assume that number of jobs is equal to the number of machines per person. Later, we will study remaining parts, whatever it is there. In our syllabus, we will be made as simplest problem only. We need to consider this problem. Number of jobs equal to the number of persons. Always matrix should be equally less. 4 rows, 4 columns. Then you can make it. This given problem we need to make an assignment with the minimum cost. Each one, person A goes to person 1, cost is 20. Person A goes to person job 2, 25. Person A goes to the job 3, 22. Like that, each one will be allocated. It's look like similarly as transportation problem, but there is a special cases. This is a minimization example of assignment problem. We will use the Hungarian method to solve this problem. Step 1. What is step 1 will be followed? Identify the minimum element in each row and subtract it in every element of that row. That is it. So, the given assignment problem will be written here. Then we will get this matrix. Based on that, first row, what is the minimum value? 20. So what you are getting? 20 minus 20, 0. 25 minus 25. 22 minus 22. 28 minus 28. We will get in this one. Minimum value taken, subtracting other values. Similarly, second row minimum is 15. So 15 minus 15, 0. 18 minus 15, 3. 23 minus 15, 8. 17 minus 15, 2. Then come to third row minimum is 17. Subtract with the third row. 19 minus 17, 2. 17 minus 17, 0. 21 minus 17, 4. 24 minus 17, 7. Then fourth row minimum is 23. Then subtract with other values. 25 minus 23, 2. 23 minus 23, 0. 24 minus 23, 1. 24 minus 23, 1. This is the way we are getting the smallest values subtracting with the other values. This is each row we are consider. Then step 2 will be previous what we are getting. From there, column wise we need to be considered. So previously we got this matrix after subtracting. In previous table, we got it each row minimum subtracting with the other values. So matrix we got it. From here, again we select it for column wise minimum and subtract with the other values. Column wise minimum, first column is 0, second column is 0, third column 1, fourth column 1. So we have to follow that procedure. So we'll get it here. First column 0 is the minimum, subtract with other elements, 0 only will come. Second column 0 is the minimum, subtract with other column, 0 only will get. Then third column 1 is the minimum, subtract with other elements. So first element is 2 minus 1 is the minimum, 1. 8 minus 1, 7. 4 minus 3, 1. That is 4, 1. 4 minus 1, 3. 1 minus 1, 0. We will get it. Minimum value is 1. Subtract with other elements. We will get the third column of new table. Similarly, fourth column minimum is 1. Subtract with other values. We will get the fourth column of new table. 8 minus 1, 7. 2 minus 1, 1. 2 minus 1, 1. 7 minus 6, 7 minus 1, 6. 1 minus 1, 0. So this is the way we will get a new value. New table of the values. Step 3. Make the assignment for the reduced matrix obtained from step 1 and step 2. So new table for each row or column with a single 0 value that has not been assigned or eliminated parts that are 0 as an assigned cell. For every 0 that becomes assigned, cross out all other zeros in the same row or column. If a row and a column there are two or more zeros, one cannot be chosen by inspection. Choose the cell arbitrarily for assignment. So above process may continue until 0 cell is either assigned or crossed. So zeros what you are getting, that should be considered. Step 4 we will be writing an optimal assignment is found if the number of assigned cell equal to the number of rows. In case you have chosen, then you can go for the step 4. Here we will be consider the new one after finding step 1 and step 2, that is row minimum and selecting and subtracting other elements, and then column minimum selecting and subtracting other elements. Then we found it. Here we used. Here what you are going to do, the previous one assigned 0. Each row or column you need to assign 1 0. So here first row no other 0, only 1 0, so I given. So first column whatever is there, then we assigned. Third one, then remaining will be cancelled. Because already assigned 1 row, 1 column. So we have to follow in this format. Then we go for the step 5. Draw the minimum number of straight lines, because make all the zeros do not have assignments. Make all the columns are which have 0 in the marked rows. Mark all the zeros that have assignment in the marked column. Repeat the steps 5 until rows and columns are marked. Draw the straight lines through all unmarked rows and marked column. You can also draw the number of straight lines by inspection. Now we can draw the minimum number of lines by inspection method of assigning zeros. The zeros will be assigned as, here you check that row wise and columns we should get only 1 0. Every row and every column. First row I am checking, there is no other 0 except 1. So only 1 0 is there. So I am going to assign that. Then that column if it is there, I am going to cancel it, because one row or one column, either row or column should be assigned only 1 0. That is job assigning. Here I have been cancelled off that column. Then second row no zeros available. In third row only 1 0 is available. So I am assigning. Third row 1 0 is assigned. Then that column again one more 0 is there, we need to be cancelled. Again the rule will be followed. Row and column only 1 0 will be applicable. Then another 0 is applicable. Here we can select third column or fourth column, however it is. But I am selecting third column. It is left to us. We can select it fourth or third one. Then fourth column will be cancelled, because already that fourth row will be selected. Now we can draw the minimum number of straight lines cover maximum 0. So first maximum zeros where is there? So here 2 zeros. First column. Then here, then here. These lines are covered all the zeros with the minimum lines. Still more it is possible to minimize. It is not possible. Minimum we should be drawn. So that so that so 4 rows and 4 columns. That means 4 by 4 matrix. Matrix order is 4 by 4. So 4 lines should be there. But here only 3 lines is possible. Now we need to make us again optimal solution. Here this is not an optimal solution because number of lines is equal to the order of the matrix. But it's not possible. Then we need to go for the next step. What is the next step? We will say the number in the matrix which is not covered by the lines, that is, what is the elements we need to take as consider as 1. Then remaining we should be 2 line passing. We need to add that minimum value. There is no line passing, subtract that minimum value, and then only 1 line passing the elements we should be written as it is. Again I'll repeat, select the minimum which is not covered by the lines. Here is 1. That 1 is the element added by the element which is passing 2 lines. Subtract the element, the lines are not passing on the elements. Elements should be written as it is. The elements is passing only 1 line. This is the condition we need to be mark. Then we need to go for the next level, next step. So look at that. Select the smallest element from all the uncovered elements. Subtract this smallest element from all the uncovered elements. That means lines, and add it to the elements which lie at the intersection of 2 lines. Thus, we obtain reduced matrix for fresh arrangement. So this is the format, previous slides we got it. This we are going to arrange the reduced matrix. This is the way we will get it. What is the procedure? We got this matrix from this matrix. Procedure is which is not covered. Then is again we are going to be make it. Then we need to draw the lines or assigning first column or first row. There are 2 zeros are there. We can assign arbitrarily. It is left to us. Okay. Here each row, and then we are getting 2 zeros. We are assigning by our own. So another one will be cancelled because each row only 1. Then come to second. Already first column is assigned, so another 0 is there, will be cancelled. Once it is cancelled, the second row first column 0, then last, that is second row fourth column, we will get selected. Then this is selected means then another 0, that of column will be cancelled. Now come to the third row, we'll get 1 0, so will be selected. Then fourth row, another 0 in the second column is there, so will be cancelled. Then third column will be only 1 0, so will be cancelled. Like this way, we need to assign each row, each column only 1 0. That is called the assignment procedure. Now, assigning the allotment. Person A, job 1 will be assigned. Then only we will make a minimum value. Person B, job assigned for 4. Person C, job assigned for 2. Person D, job assigned for 3. This is the assignment will be given according to the optimal solutions. Since the number of assignment is equal to the number of rows, see that we can cover in that way. Then total cost assignment A to 1, B to 4, plus C to 2, D to 3. From the original problem, that means the given question, what is the value which is assigned in the 0 which is mentioned in the boxes, that value should be considered. A to first job assigned will get 20. B2 fourth job assigned will get 17. C2 second job assigned 17. D2 third job assigned 24. Therefore, total assignment minimum cost equal to 78. This is the way we need to find out assignment problem. Take out the another question. Here also we need to be remember that what are the procedures we have been explained in the previous problem. So similar way, we little bit understanding and then going. First step what we are going to do, select the row minimum and subtract the other elements. Second step, select the column minimum and subtract the other values. Then we need to assign the zeros, or we can draw the number of straight lines. The straight lines which you are satisfied the order of the matrix, then we go for the assign. Each row, each column, only one zero will be assigned. That is satisfied means we will get a optimal solution. Then we can go for the finding the values of matrix. Now this problem again I am going to explain the assignment problem or Hungarian method problem. So will be followed this procedure. First one, the following matrix gives the cost incurred if the type is A, B, C, D and E. Execute the job PQRST. So this is a matrix. Here each row will be selected as minimum value. First row, what is the minimum value? 65 will be considered. Identify the minimum element in each row and subtract it from every element of that row. Minimum is 65. Second row minimum is 66. Third row minimum is 57. Fourth row 60. Fifth row 56. Then we will be finding of this. How we find out? 65 subtracted from first row. 85 minus 65, 20. 75 minus 65, 10. 65 minus 65 we will get as 0. 125 minus 65, 60. 75 minus 65 will get 10. Similarly, in second row, 90 minus 24 will get 90 minus 66. And then 90 minus 66 will get 24. 78 minus 66 will get 12. 66 minus 66 will get 0. 132 minus 66 will get 166. 78 minus 66 will get 12. Similarly, 75 minus 57, 18 will get 66 minus 57, 9 will get 57 minus 57, 0 will come. 114 minus 57 will get 57. 69 minus 57 will get 12. Come to the next row. 80 minus 60 will get 20. 72 minus 60 will get 12. 60 minus 60 will get 0. 120 minus 60 will get 60. 72 minus 60 will get 12. Then come to last row. 76 minus 56 will get 20. 64 minus 56 will get 8. 112 minus 56 minus 56, 0. 112 minus 56 will get 56. 68 minus 56 will get 12. So this is the what I done here. Selecting the each row of minimum, subtracting the other values. Then we'll get the new matrix of this. Then we'll go for the next one. Next one procedure is selecting each row of minimum. Then subtract the other values of the column. Okay, identify the minimum element in each row, each column, and subtract rows over. Now columns will be selecting. So first column 18, so we will be selected and subtracting. Second column 8, third column 0, No need to do, all the columns are 0. Then fourth column 56, fifth column is 10. So now I'm subtracting, we'll get this column. Here what is that in the column? 18 is the minimum, 20 minus 18 will get 2, 24 minus 18 will get 6, 18 minus 8 will get 0, 20 minus 18 will get 2, 20 minus 18 will get 2. Similarly, second column, that is Q column, minimum is 8, subtract with that, 10 minus 8 2, 12 minus 8 4, 9 minus 8 1, 12 minus 8 4, 8 minus 8 0. Third column already 0 is available for all the values, so as it is will be remain. And then fourth column 56 is the minimum, subtracting with all other elements. 60 minus 54 4, 66 minus 56 10, 57 minus 56 1, 60 minus 56 4, 56 minus 56 0. So we will get it in the sum. Then last column, that is T column, minimum is 10, subtract with other elements. 10 minus 10 0, 12 minus 10 2, 12 minus 10 2, 12 minus 10 2 will get in that fourth column. This is the new matrix. Now what we are going to do, we need to assign the zeros or make the assignment or the reduced matrix. First row 2 zeros are there, so we need to assign this matrix assigned to right side matrix. So first one will be 0 because second row only one 0 is there, so I assign easily. Then for that particular column everything will be cancelled. Just one is assigned, so we can cancel because each row and each column only one 0 will be assigned. Then come to next one. See that first row only one 0 is available, I assigned. Come to the next one, third row only one 0 is available, assigned. In that fourth row no 0, then fifth row only one, either second column or fourth column we can assign, it is left to us. So I selected second column, then fourth column will be cancelled. Now how many zeros assigned? 1 2 3 4, but order of the matrix is 5. So A B C D E F or P Q R S T, 5 is there, so this is not satisfied, then we go for the optimal finding solution. Then the number of assigned cell is not equal to the number of rows or columns. We draw the minimum number of straight vertical lines and horizontal lines. So we need to draw that. This will be your maximum will be, we'll get that. This is a maximum, 0 will be covered. Then other lines, 1 will be covered. Then 1, then 1. That's it. Order of the matrix is fine, but number of straight lines drawn only 4. So this is the not a optimal solution. This is not a optimal solution. So we need to go for which is not covered by the line. We need to select as minimum value. Here is 2. What you have to do? The lines passing through, two lines passing through the elements will get added. There is no lines passing through the elements, so will be subtracted. As it is will be written only one line is passing through the elements, so we'll get the matrix. So as it is we explained, so we'll get, so what we are done here is done as previous table what we studied. Here two lines passing, we need to add the minimum. Here is the minimum is 2, so add with the minimum. Only one line is passing the elements, will be written as same. There is no line is passing through the elements, then we can write subtracting the minimum value. Minimum value is 2, we need to be subtracted. So once we will be subtracted, we will get this element. Then we need to draw that. First row, there is no other 0, only one 0 we assign. Then that column will be cancelled. Come to the second row, only one zero is available, that column will be cancelled. Another zero cancelled. Then third row, only one zero is available and that column will be cancelled. Then second column or fourth column has been possibilities. Then we can go for the one zeros assigned. Here you see S column, that means fourth column, no zeros are available because we assigned one zero, we not be assigned. Then again we have to be for the optimal solution finding method, we need to follow that. So here again need to be followed this one. Then we need to draw number of assigned cell is not equal to that, then will be followed, draw the straight lines. Maximum zeros covered, minimum number of lines, second line, third line, fourth line, all the zeros are covered even though it is not getting a optimal solution. Again we need to collect, first to select that the elements which is not passing the lines. Here is minimum value is 1, that minimum value you should consider. So add 2 lines are passing the elements, subtract no lines are passing the elements, only one line passing as it is should be returned, that should be carried for next level. So Hungarian method final table will get, after finding all the information, we'll get this table. What is the methods of followed in previous slide or previous table? Selected the minimum value, add with the 2 lines passing the elements, subtracted no lines are passing the elements, as it is will be written only one line passing the elements. Now we can assign that 0 for each row and each column. We will get first row, you see only one 0 is available, so remaining 0 in the particular column will be cancelled. Come to the second row, only one 0 is possible, in that column another 0 is there, will be cancelled. In third row there are 3 zeros are there, we need to give, we are not able to assign, then go to the fourth row, will be assigned 1 0. Then third row 1 0 is there, then will be that particular column will be cancelled. Then second column and fourth column, 2 zeros are available, equally you can give an opportunity, you can select it, however you understood that. Okay, here we can alternate. So this kind of problem is called multiple solutions. I'll get, so I'm selecting here, so I'm cancelling here at the same time here, then I'm selecting here, then I'll be cancelling. Now you see each row, each column 1 0 will be assigned. This is the optimal solution, that is final solution of the Hungarian method. Till the process we need to be proceed, selecting minimum, subtracting other, like that we need to proceed. Assignments will be given a to 1, what is the value in the original problem, 75. Here it will be selected for all the zeros, then we can go for the assignments. This assignments will be A to T 75, B to R 76, 66, C to S will be 114, D to P is 80, E to Q is 64. So this is the value. This value is found from the original problem, given problem. So this is the value we'll get. Then since the number of assignment is equal to the number of rows, so satisfied, then we'll get an optimal solution. Then we'll go for the substituting the values from original table, we'll get the value 75 plus 66 plus 114 plus 80 plus 64 equal to rupees 399. This is a assignment problem, minimum cost of the value. This is the way we need to be find out assignment problem. Thank you for watching my videos. Any doubts or any corrections is there, you can let me know. I will be explained in the whichever your queries and doubts is there. Thank you for watching. We'll see you in the next unit. Here ends second unit of Operation Research, second sum UVA Aviation Management. Thank you.